Okay, let's go ahead and go over the oxidation numbers and wait, I didn't actually have you name those? Oh yeah, yeah. Okay, good. So oxidation numbers for the first compound, what do we got?
Al+3 and -3.
How do you know it's Al+3?
Because aluminum always has a charge of +3.
Because aluminum always has a charge of +3. If you look on the table, aluminum just has the one oxidation state, so its charge is +3. Plus it's in that column 3A, and so those guys have a +3 charge in that column. And then, do you need to look at the nitrogen?
No.
No, there's only one thing there, so it's just -3. Does the -3 make sense though?
Mm-hmm.
Why?
It needs to equalize.
Another reason.
3 electrons
3 electrons
would fill nitrogen's.
would fill nitrogen's energy level to look like neon, so 3 totally makes sense. Okay, the next one? How about the potassium?
Plus 1.
How come?
Because there's 2 potassiums in the oxygen.
That's not why.
The oxygen is
That's not why. You don't know that.
Because
Oh, it's not a.
Because potassium's always is group 1 metal, so it's always +1. That's what you know. You know that for sure. And now, you can say what you said.
Oxygen is not -2.
Because the potassium is +1+1. Not the other way around. Why not?
Because oxygen's not always the same.
Because oxygen's not always, just almost always.
Almost
And the next?
always.
How come? Group 1 metal, it's always +1. H? Why? This is tough.
Paired with the metal.
Say again?
It's paired with the metal.
No. The answer to paired with a metal is -1.
Oh, non-metal.
It's paired with a non-metal.
Oh,
How is it paired with a non-metal if I just said sodium?
because it's in the
Because that's a thing. What is that? Polyatomic ion. So the H is with the CO3, not with the Na. Okay, so then the carbon's charge? Because the oxygen's charge is -2, and then everybody equals, the whole thing equals 0. Next one? Why? Because it's group 2 metal, so it's always 2. Carbon? Oxygen? Okay. Next. Why? Group 2. And then the hydrogens
Plus 1.
and the oxygens.
-2.
So -2, -2, -4, +1, +1, and then +2, so they cancel out. Everybody all cancels. Okay. Okay, let's name these guys. So what's this first one? Excellent. How come I don't need to say anything about the aluminum's charge? Because it's always 3, so I don't need to indicate that it is 3. And then where'd the "ide" come from? It's just what you do when something becomes negative. And that nitrogen gained 3 electrons, so it did become negative. Name for the next one? We okay with that? How come it's not like potassium 2 or dipotassium? Because if it gave a number that indicates the charge, and the charge isn't 2, it's 1, so that's a good reason. And that's just how we name ionic compounds. How about the next one?
Sodium bicarbonate.
What is it that I need you to recognize in this question, in this formula?
Polycompound.
So you need to just be able to name that guy, which used to be called bicarbonate, but is now hydrogen carbonate. So if you've heard the term bicarbonate before, somebody's got an upset stomach, they should take a bicarbonate. It's any compound that's got a hydrogen carbonate in it. It's usually a sodium hydrogen carbonate or potassium or calcium or magnesium or something. Are we okay with that? Easy. Next one?
Calcium carbonate.
Okay. And this last one?
Magnesium hydroxide.
That is correct. Why do I just get to say magnesium hydroxide? How come I don't indicate hydroxide numbers or anything like that?
Magnesium was a +3.
Yeah, you just don't do it. You're just supposed to know that that magnesium's a 2 and the hydroxide's a 1 charge, and that you need 2 of them to go along with the 1 magnesium. So what do you have for a formula for this one? Right, skipped one. But we're doing the first one.
ZNS.
Nope. Are we okay with that? Sulfate's SO4 minus 2 and zinc's charge is +2 always. So then it's just ZnSO4. But since tin does not have a consistent oxidation state, I have to tell you what the charge is. So I told you that it was tin 2, so then what's the formula?
SnCO2.
Yep. How about this next one? Why is it Na3PO4? Because it's a -3, the phosphate. So then, since the sodiums are each +1, I'm going to need 3 of those to cancel it out. There's a really, really, really common name. We talked a little bit about common names last time, right? Like water was the common name for dihydrogen monoxide. Actually, I think I talked about that in the other class. So water is the common name for dihydrogen monoxide. Ammonia is the common name for NH3. And there's a common name for this, and the common name that you might have seen at a grocery store or at a hardware store is TSP. Somebody ever used that before?
Teaspoons?
No, not teaspoons. These are all capitalized. It stands for trisodium phosphate, which actually makes sense, right? Even though that's totally not its name. But its super common name for this is TSP, and it's used as a heavy-duty cleaner for things that are waxy, like floor wax. When you put this on the ground and there's floor wax that needs to come up, like they do at every school in the country during the summer, the TSP turns the wax into soap. Next one. Ag2S. Are we okay with that?
I won this whole last part.
Somebody have something different than Ag2S? You only have one silver? Is that what you said? Why is this the formula? Silver's always one, and sulfur's in oxygen's column, so in a typical ionic compound, it's gonna be a -2. And then the last one? Yeah, I gave you that one again. Okay.